Hello everyone, this is Sonali. Today I'm having Manoj with me as a co-host and amazing speakers like Saurabh, Naresh and Sandeep with us. So we will start today's our interview brainstorming session. Thank you so much guys. I will start. I will ask first question to Sandeep. Okay.
Yes.
The question, yes, Sandeep. The question is, your application processes image uploads from the millions of users, but traffic is unpredictable. So, would you use a Lambda or EC2 for better and explain why? Means that you whatever the your application you are working with that application that is processing the image uploads and from the millions of users they are uploading the image at that time traffic was unpredictable. So in that scenario how you are going to move ahead means you are going to do give the solution with the lambda or ec2, what is the better, that thing you have to
Yes.
explain.
Okay. In this type of scenario where the traffic is highly unpredictable, sometimes it's slow or maybe sudden it will get spike. So we need to give solution based on the solution will be scale quickly, avoid overpaying, over provisioning of resources, and keep the cost low during the less traffic. So let's consider the both options for the EC2 or the AWS Lambda serverless. Or if you take the EC2 traditional server, so it will always running uh, for the traffic. So whether the traffic is low or high, so you can pay for the uptime of the resources, not for the actual use of the resources. Here we use the auto scaling uh, for the scaling of the instances based on the traffic increases or down. So and in EC2 model, uh, we need to handle all the uh, in term of we have to uh, uh, we have to adjust all the auto scaling rules, maybe manually, or we have to configure all the rules by by itself. So next go for the AWS Lambda serverless function. So in AWS Lambda it is a event driven technique where the code runs when an event is triggered. For example, when an image is uploaded to the S3, so then and only the event is triggered and image is processed uh, based on the logic or the code. So here auto scaling is very fast compared to the EC2 base system. So it will be uh, upscale or instantly scale the from zero to thousands of requests in a second. So and this AWS Lambda service is a managed service. We no need to maintain anything here. It will be take care by the AWS itself. So and for the uh, what we can pay. So you are charged only for the execution time and the memory used. So no idle cost here than the EC2. So the it supports the multiple runtimes like Java, uh, .NET, Lang. So in combination for the unpredictable event-driven workloads like image uploading, I would choose the AWS Lambda over the EC2. Lambda scales instantly with the with demands, and there is a no cost when it is idle, and it integrates easily with the S3 for the event triggers. And if you take EC2, it would fit for the steady or predictable traffic workloads. But in this case, I would choose or prefer AWS Lambda for the scalability and the cost optimization. So that's from my side.
Yeah, very good and detailed way answer you given, Sandeep. So just I will add some of the things here. Predictable traffic means sometimes you will get very few requests, and sometimes you will get millions of requests. So that is the thing we can call as unpredictable traffic. If you call about serverless, there is no need to manage anything about the serverless. All the things is managed by the cloud. But if you talk about the EC2, so we have to manage all the things, all the infra we have to manage. And you compared very well about the scaling, cost efficiency, traffic handling, and all the setups. So while comparing these factors and by considering this scenario, we can say that AWS Lambda is better for these unpredictable workloads because it automatically scales and costless during the ideal periods. So, if you talk about the EC2, so that we will face some of the downtime, and when ideal is there, then also you will get the cost. So, comparing the both the terms, we will go for the AWS Lambda serverless technology. So yes, now thank you so much by giving the clear and crisp answer, Sandeep. We will move ahead with the next question. Manoj, you ask next.
Yes. Hi Naresh, I'm going to ask this question with you. And the question is like we have one e-commerce platform and we are experience unpredictable traffic. We are suspecting that one because we are doing flash sale from last 3 or 5 to 5 years. And how you will help us to do this auto scaling during this flash sales?
Okay. Mm, uh, for example, auto scaling means we have to dynamically adjust the number of resources when the traffic increases,
Hmm.
and we have to decrease the resources like EC2 instances and containers.
Yes.
We have to decrease when the traffic decreases. We have to configure the auto scaling group like we have what are the minimum instances, how many maximum instances, and desired instances while configuring the auto scaling. And we have to follow the auto scaling policies like dynamic scaling and scheduled scaling. Dynamic scaling means whenever the traffic increases, it automatically increases the capacity based on metrics. uh, Scheduled means particular time when the event begins. We have to pre-plan scaling before an event, 10 minutes before, like that. And we have to configure the cloud watch metrics to monitor the CPU network and request count. And it automatically triggers when the scaling increases. It increases the resources automatically. And if we take any real-time example as given in the scenario flash sale, um, we have to configure the metrics like if the CPU is greater than 75%, this much of instances will be increased. If the CPU is reached to decrease to this percentage, see, then we have to decrease the instances. Like that, we have to configure. For example, flash sale is started at morning 10 a.m. uh, then the request will be before the flash sale 200 requests. When the flash sale starts, the request will be more 2000 requests. Then the CPU will be increased to 75%. Then CloudWatch detects that CPU, then it will increase the instances to 8. More than uh, minimum is 2,
then it will increase the 8 instances. Again it will increase the 80%, then CloudWatch detects, and again it will increases to maximum 20 servers. After increasing, we have to use the load balancer also. It will distribute the traffic to new servers. Like that, we have to configure the auto scaling group and the CloudWatch. Then it would be good for customer experience, for his smooth transaction with no downtime.
Yeah.
Yeah, so that's it from me.
Yeah, thanks, Naresh. You covered almost all the core points, and also you you also covered how you are configuring this auto scaling. Also, you explained very well. Okay, just I want to add some other points to this, whatever you explained to us. Here, as I mentioned, this is unpredictable. As you took that the dynamic, that is very impressive move, and also very impressive point or auto scaling features you gave. And just I want to add like that, when our flash sale is started, or when flash sale normally started in e-commerce, then we can't make sure that our like a customer are reaching our portal after our sales only, after our flash sales only. Before that one also, we have the customer is reaching to our platform. And also when our flash sale starts, then immediately customer will hit our applications. We have some multiple scenario also during this flash sale. To overcome that one scenario, we are using layered this one auto scaling. Okay, means as you mentioned dynamic auto scaling, we are including that one also in our auto scaling layered auto scaling feature. And also we are including another two auto scaling. One is predictive auto scaling, one is this what we can say scheduled auto scaling. Okay, we are combination of these three auto scaling, we are preparing one layered auto scaling, and we are facing this unpredictable traffic during our flash sale. Means how we are configuring like that. First we will schedule first auto scaling, that is a scheduled auto scaling at the 11:55, means our before 5 or 10 minutes our midnight flash sale, so that it will bring up our all the bots, server, everything, and then it will make sure and ready our platform to handle the incoming customer to our application. Okay, and the second one, we are scheduling our predictive auto scaling. And this one, why we are adding here, because last previous 2 or 3 years we already captured that. Like we will get some people between auto scaling start after 20 minutes like that, or before 20 minutes like that prediction we have. So to overcome like that rush in our application, we are using this credictive auto scaling. And after this one, we are using a dynamic auto scaling also, because if you see, whenever any celebrity or anyone give any messages in what in the Instagram, Twitter, anywhere, like in this application, in this e-commerce, this product is very good like that, then his or her followers also start buying that, coming to our platform and start buying that. In that case, we need to handle that traffic, so that we are using this dynamic auto scaling. It is quickly increase our CPU and request based on our metrics, as you mentioned metrics very clearly. On based on that one, it will increase the dynamic scaling. So like this, we are facing this unpredictable auto traffic during our flash sale. Okay, that is some more information about this. Yeah, you can go with next question, Sonali.
Okay, great explanation by the Manoj and detailed explanation by the Naresh. Thank you so much. We'll go ahead with the next question. I will ask next question to Saurabh. The question is, there is a ticket booking site sees extreme spike during the concert or sport events. So how would you design an elastic architecture to handle this?
Okay, so for the ticket booking sites that can explain the sudden spikes during the concerts, sports events, and festival season time. So electricity is essential. So elasticity means that the ability to dynamically increase or the decrease the resources as per the workload demand according to the user. So how we can implement that part? So we have to use the baseline capacity. We can run the minimal set of the EC2 instance and other instance during the normal traffic periods. And after that, we also set up the auto scaling to automatically launch the additional instance when the traffic increases, and based on the metrics such as CPU utilization and the memory utilizations and the request counts or latency. And and also we have to add the application load balancer ALB to distribute the incoming requests evenly across the all available instance. So and also we uses the content CDN integration. Uh, so you use that using the Amazon CloudFront to catchy and deliver the static asset like the event posters and set maps and script closer to that user. So it can easily came across to that nearby the user to reducing the server load. So popularly, we can take the example like that during the popular concert ticket release such as Book My Show. We have to mention Book My Show and the cricket match ticket, and in also we have to see in the Paytm. Uh, in there, we have to see the when the cricket match is announced. So the ticket on that site there is a more traffic unusual that. So it is unable. We have to load and the means book that tickets. So for that, the traffic might spike from the few hundred to the 10 of thousands of the concert user in a second. So auto scaling it's made a major part, provisioning the more EC2 instance to handle that search. So auto load balancing the direct request evenly, and the cloud front reduce the origin the load by serving the static content from the edge location. So when the demand drop, this auto scaling terminate the extra instance and avoiding the ideal cost for that. So this is my approach toward that.
Yeah, all the things you explained very well, way. So here you took the example of Book My Show. So that is properly matching with the scenario. So you already told about the Book My Show. There is ticket booking application. If suppose one famous movie came like Bahubali or RRR, so at that time traffic spike 10 to 15x in a minute. So if we cannot auto scale, or we cannot scale our application, the site will crash or customer get frustrated, and we will face revenue loss. So to solve this particular problem, we are going with the multiple layers. What we are going with the first edge layer. So for the architecture, we are adding edge layer because the edge servers storing the static data. Suppose whatever the movie poster is there, seat layout, show timings, show ticket price, that all the static data we can store in an edge location. So for the customers, for the traffic, they will not face any latency during that time. So second layer, we can think about adding the EC2 auto scaling group. So when traffic is increasing, we are adding the servers. When traffic is drops out, we will reduce the servers. That thing we can go ahead. And for the queue, booking queue, we can use Amazon SQS service. So that whatever the first come, first out. In this sequence, they will get a ticket booking. So suppose there is some person is booking tickets online. Some they will hold one or two seats. So that time also, for that we'll going to use seat hold payment, means that we will give as a this is reserve. So for that purpose, we can use a Redis service of AWS. And if the particular times out or if anything failure happen, we will release that seeds. So that thing we can do. And for the RDS, whatever the database is there, for that database, we can keep that database in multiple layers. So suppose if database, one database is down or some disaster recovery is happen, then we can redirect the traffic to the, we can use another database also in that condition. And we will assign the monitoring. So we have to monitor the matrices. Depending on that matrices, we can scale out and scale in our applications. So these are the main important things we have to focus while building our elastic architecture to handle this particular scenario. So we'll go ahead with the next question.
Yeah.
Yes. Manoj, you can ask the next question.
Okay. I'm going to ask this question to Sandeep. Okay. Sandeep, our question is like this. We have business critical application, means you can also call it as mission critical application. And we customer is requested us like they required 99.99% of uptime of their application. And how would you ensure this uptime, and also how would you ensure this fault tolerance of this business critical application?
Okay, let's go through the architecture for the fault tolerant. So first we consider we can set up the multi Azure multi availability Z deployment. So run the applications on EC2 instances in at least two availability zones within the region, and use a use a application load balancer to distribute traffic between these availability zones. If the one zone is fail, so the traffic automatically shifts to the uh, next a healthy zone. So then next week set up the multi-region multi-region setups for global redundancy. Deploy active or active passive architecture across two regions. For example, we can deploy one application in US East region, or second in US West region. So so we can use Route 53 with latency based routing for the active approach, or failover routing using the health checks for the active passive approach. So so next will be database. How will uh, uh, available data, highly available database. So use the Amazon RDS multi availability for the relational database. So when automatic failure to the standby location, or for the global availability, we can use the Aura global database for the global availability. So next will be the stateless applications, stateless application design using the caching or CDN, content delivery network. So CloudFront for the global content delivery, that ensures the static assets are always available to the available from the nearest edge location. Then we use Redis for the multi-Azure mode to reduce the load from the database. Then we consider the backup and recovery. So for this, we enable the EBS snapshots and S3 cross regions replication for the disaster recovery. And then next we take or consider the monitoring and the auto healing. So integration with the CloudWatch metrics and alarm, it triggers auto scaling based on the metrics, crosses the limits and the auto scaling replace the autoclaves replace the unhealthy uh, instances automatically and send the traffic to the uh, healthy uh, healthy instances. So to achieve the 90.99 uptime, I design the architecture like multiple availability zones and setting the multiple region architecture with the Route 53 failover
Hmm.
or using the application load balance for the traffic distributions and auto scaling of the EC2 or EKS instances. That's uh, like that we can achieve the
Yeah, Sandeep.
99 point of time.
Yes, yes. As you covered this scenario question, whatever key points which is hide in this interview question, that's you explained very clear like that. No one can easily understand. You just explained fault tolerance and also active and active passive, and you are how you are going to explain that active right, and that is very good. You as you choose the active site, and also route 53 also you explained, and also you explained this uptime and also other services of AWS, how you are shifting the traffic from one side to another site when there is any issue. This is a very good point for this use case while in explaining these things. And I just want to add the another one thing, like here as you mentioned uptime rate, just I want to explain more little bit. And here uptime as means when customer is asking 99.99 means in the whole day means 24 hours, they just only accept only 8 seconds of downtime. If that is more than 8 seconds, they are not able to tolerate that downtime. That is called basically this uptime. And whatever you explain the active I that's very good. And in this mission critical application, always we are using architecture, and also we are using the failover. Means if any site is goes down, directly it is routing to the another site, the traffic, if there is any health check response is not coming up. And also as you mentioned the auto scaling group, that is also one good feature during this fault tolerance. Means when any node is down and it is not came up before 1 minute, that time we are terminating that node and instantiating another node with the same configuration. That is also one good feature you explained during this one. And also another one point, like database things, as we need to make a machine critical application, so we need to keep database in multi zones, so that we don't, if any one zone database is affected, then it will still running from another zone database. So in that the same time we will fix our issues, and we can make our application more stable without and also here we are not giving any clue to customer or any clue to this user, so that our application is facing some issue like this we are doing. And also as you mentioned storage, those things, yeah, is to store our very objects and files, so that if we are not want to lost that files. If they are lost, then maybe we will face some more issues. So as a keeping in S3 bucket is very good options. And also network layer, as you explained, S3 DNS routing, and keeping multiple availability zones. And also you explain that this one east and west, that is also very good options for our mission critical application. This is a points which I noticed and which I impressed from your explanation for this use case. Yeah, we can go for our next question, Sonali.
Okay, sure.
Yeah.
So, next question I will ask to Naresh.
Yeah.
So, the question is, a startup is paying too much unused resources during the peak hours. So how would you fix this? Suppose you are
Okay.
working with one of the startup, and there you are paying too much bill for whatever you are not using the resources in the peak hours. So how you going to fix, or what exactly solution you are going to give in this scenario?
Okay. First, I will take one example for the startup. Like I will take food delivery startup. Like food delivery startup uses AWS instances to run their platform. What are the peak hours to food delivery platform? Means from 11 a.m. to 2 p.m. and evening 7 p.m. to 10 p.m. Is peak hours. Okay, remaining time is no, there is no orders, but that's why there is no peak hours. We have to set up like this, like 10 instances are running. Each instances for 1 hour they charge $1. For example, if we take even at 3 a.m. also, they still have 10 servers running, but during that time 2 servers are required. That's During this time we are unnecessarily wasting 8 servers. Means if we think $1 per one server, uh, we are wasting $192 per month. We are wasting. That's why we have to solve by using auto scaling plus scheduling. For auto scaling means configuring AWS auto scaling groups to scale up during high traffic down and down the low traffic. Like we have taken example, right, from 11 a.m. to 2 p.m. and 7 p.m. to 10 p.m. During this traffic only, we are scaling the EC2 instances, and off peak hours, it will down the uh, EC2 instances during by using auto scaling. If we take scheduling also, uh, if traffic is predictable, we have to set the rules to reduce the capacity at midnight and increase the capacity at 11 a.m. AWS has scheduled actions for this. This is ideal if we know the peak hours, like we have taken in our example. And we have, if we take serverless, uh, serverless means pay as you go model. How much we have to use, that much only we have to pay. For some workloads like use AWS Lambda, Azure functions, or Google Cloud, uh, for that how much we have to use, that much only we have to pay. um, if we use APIs or background tasks that don't need 24 by 7 dedicated servers for this, like by using auto scaling and scheduling, we can resolve this issue.
Yeah, great explanation, Naresh. So as I told, auto scaling. Yes, we can, for the scaling and scale down purpose, we can use auto scaling. But yes, we can transfer some load in AWS Lambda, that is the serverless server also. So we can combine auto scaling and serverless together to manage and to give the perfect solution for this scenario. And we can use some spot instances for non-critical workloads, or we can use saving plans or reserve instances, so we can save some amount from that. That things also we can do. And we can like use CloudWatch service to matrices, to monitor the matrices, and depending on that we can schedule the RDS and our service, serverless service, and auto scaling. That thing we can manage the things. So as you explained, all the things you explained properly. Yes, thank you so much, Naresh. Thank you
Okay,
so
thank
much, all of you.
Yeah,
Yeah.
thank you.
Yes. If you want to reach, yes, here is contact details, LinkedIn details. You can reach out to us if you have any query, or if you are still getting rejected in the interview. because you don't understand the scenario based questions, or because you don't have the real time practical knowledge, or you haven't did enough project. So you can feel free to reach out to us. Thank you so much.
Thank you. Thank you, guys.
Thank you.
Thank you.
Thank you. Thank you, guys.